LZMap and LZReduce, I can then manipulate the data that's being requested and return something completely different back to my verification, ultimately to have it executed back to my contract. So what this ultimately builds to is this ability to essentially initiate a request from any chain and bring specific state back on chain that you want. The example that we'll be going through today is actually fetching live Uniswap ETH to USD pairs from multiple different blockchains, aggregating that price off chain using our DVNs, and then bringing it back on chain as a request. For this workshop, if you go ahead and scan this QR code, it'll give you a Linktree link. This Linktree will have links to the example code that I'm using, to the relevant documentation about LayerZero Read, and then also just more information about LayerZero in general. Cool. We're going to jump into the code example, and I'm going to show you exactly how to get started. I have two windows pulled up here, one that I've already deployed, and then one that we can base our contract off of. The first thing that we're going to do is go ahead and use LayerZero CLI tool to get started. The simplest way to do this is running LZ enable read example equals 1 in your environment, and then this command npx package, create LZOApp at latest. What this command will do is basically create a prompt for you to build a new repo. In this case, I've already created one, but I'm going to call this myRead2. It'll give you a list of contracts that you can start from. There's OFT, OAP, ONFT, some upgradable variants if you want. In this case, I'll do OAP read. This is the one that has all of the read contracts installed. Pull all the dependencies down that I want to use, et cetera, et cetera. In the meantime, what's happening in this contract is that OAP read is just a simple example contract based on this standard, OAP read here. OAP read you can find once these dependencies get pulled in node modules, but in the meantime, I actually have them pulled up for us here already. We can go ahead and bring this contract up. I'll actually walk you through live really quick how this Uniswap V3 quote demo works. So at a high level, I'm going to pull terminal down really quick and just get all this stuff sorted. Perfect. The Uniswap V3 quote demo is just an extension of OAP read. OAP read itself is just an extension of OAP, the base cross-chain messaging contract. The only difference that we're actually doing is setting up one function, a read channel. The way that read works is that you can define specific messaging channels that you want to send to, and then use them for constructing your data requests and compute logic. In this case, looking at this contract, I've defined a couple main constants. First, just a chain config with the Uniswap V3 quoter address for the target chain that I'm looking for, the token in address for wrapped ETH, the token out for USDC, and then also just defining these constants here directly in the contract. You can see here that each chain has an endpoint identifier that I'm using. In the constructor of this contract, I'm setting up the LayerZero read channel. The channel ID is just an arbitrary identifier for where I'm going to be sending to and how I'm going to be reading from. And then for each of these chain configs, again, just pulling all of the relevant Uniswap V3 pool contracts for iQuoter V2 and setting them up here. The way that this read average Uniswap price function works is that we're essentially generating a read command and then passing it to the normal LayerZero send method that you would use. The only difference being we're passing the read channel as the endpoint ID and a command as opposed to our LayerZero message. Under the hood, the way that get command works is that it is a standard function that you want to set up within your application. This get command will basically define the number of call requests that you want to have executed cross-chain. In this case, I'm just using the number of pairs that I've been putting, 3. And I will define basically as call data the type of params that I want to essentially use as call data on these target networks. Here I'm using the iQuoter V2 from Uniswap V3, quote exact input single params. I'm encoding this as call data for this function selector, and then generating in this for loop the number of read requests for each of the chains that I want to read from. Under the hood, the second thing that I'm doing is defining a compute request. The compute request is basically how am I aggregating all of this data once it's returned. There are a couple compute settings. If I do, for example, compute setting 0, this is LZMap. If I do 1, this is LZReduce. Let me just fix that, not LZmeow. And then 2 is LZMap and reduce. Again, you can look for these function methods wherever you like. In this case, we're looking back on the same chain at this address. The function LZMap is basically deconstructing for each response what is the actual output. So in this case, we're getting the response from the Uniswap contract of 4 main return types. The only one that we care about is the actual amount out that's being returned. And then LZ-reduce is defining, once we have all of these aggregated responses, you can see here, we're getting a bytes array of call data for responses. We're taking all the responses that we get from each of these chains, aggregating them, and then just doing a simple average to basically get the average amount out from each of these networks. And then finally, the only thing that I'm getting back in LZ-receive is what is produced from the ABI encoded argument here in LZ-reduce, delivered to my contract on chain. So high level, walking through this again, we construct in the send call a command. That command is comprised of both the requests for data that we want to go get on different target networks, the call data for those chains, and the actual address that we're quoting from, and then some compute settings. In this case, looking back on the source chain for LZ map and LZ reduce to go and aggregate this function logic. And what's cool is that these functions will get executed off-chain bar DVNs that we've configured, and then only this final ABI encode from LZ reduce will be delivered as a message to LZ receive. So a lot I kind of went over there. Let's actually look at this kind of in action a bit more. We're going to zoom out here. I'm going to pop into Arbitrum. First, I'm going to query this quote price for the transaction I'm going to do, in this case in Way. What I'm going to do from here, too, is then grab this Way price, go to Ether converter just to simplify this process a bit, punch in the conversion to Ether, then go to write contract, read average Uniswap price, throw the amount in, don't have any extra options that I want to add. We'll write on the block explorer this call, hit confirm, and what will happen here is it'll generate this transaction on Arbitrum for us that got confirmed basically instantly. And then we can go into LayerZero Scan and actually see what's happening under the hood here. Inside LayerZero Scan, this basically just serves as a record of all transactions processed by the protocol. It might take a second for it to index and come through. Here we go. You can see that we have a request transaction hash from Arbitrum, and we're waiting for the response transaction to land. You can see here that we have a request payload that we generated. There are some decoding instructions that you can follow from the documentation about how to decode any incorrectly constructed calls that are made here. But what will basically be outputted back on chain while we're waiting for this one to land is the aggregated price from all of these different networks that we're reading from. One of the things that I've done here as a transaction already is reading the average price earlier, I think 2 or 3 days ago. We can basically see here that we're getting executor fee paid, DVN fee paid on the send side and the packet sent event. And then from the overview section here, if we go and add this transaction to Tenderly, this one's already been indexed. We can see the destination here. Open it up, go to our logs, and we can see the aggregated price for ETH a few days ago was 3307, looking directly from all of the Uniswap pools that we have configured. So what this basically enables you to do is take data in the form of a call data request that we saw here, aggregate from that call data request the responses and return values that we get on chain from any type of view or pure function or public state variable that's on a destination blockchain, and then use the LZ reduce and LZ map methods to basically take all those requests that we want, aggregate them down to one final response payload, and then deliver that response payload to LZ receive. So yeah, I hope this gave you kind of a good overview of how LayerZero Read works. Now open any questions you guys might have about the protocol, about cross-chain messaging, read messaging, things like that. Sure. Yeah, sounds good. Yeah, thank you guys. Oh, I have to jump on.